There
you
we
go.
All right, so what is it that we're doing today? We are going to be starting off with this sorting activity, which we'll go into in a bit right now, but it's titled 1S because it's a sorting activity, and you're going to be getting a lot more of these going forward since we are trying to determine the difference between linear and exponential functions. We're going to be sorting things into a linear function or exponential function. That is the first thing. If you actually want to be ready, you can already click on that. Okay, do that whole process of logging in or typing in your name the exact same way every time. So you guys can already be getting started on that. But right after we're done with that sorting activity, we will be finishing up our week 5 notebook today. So today is our last day for this week 5 notebook, and that'll be the last pages on there, which is page 4 or slide 4 and slide 5. There's a page of notes and a page of your turn. Then we're going to go over your homework assignment for tonight, which is identifying exponential functions. You have tables there, and all you really need to know is this exponential or not? We don't care what else it is. We're just trying to see if it's exponential or not, but we'll review that. And that's basically it for today, those 3 things. But remember, if you want to access the recording of today's lesson, you can always go back into your agenda for Friday, click on that video of lesson. As soon as you see it underlined, it'll have that link to the YouTube recording. And since today is Friday, we are giving you a progress report just so you know where it is that you're at, if you have any missing assignments that you might want to complete this weekend. Remember, all of our assignments from this week are due by Monday, and we will be updating grades again by that Tuesday. So make sure you are paying attention to those assignments that you're missing. Try to get as many of them done so you're on track. Other than that, there is one assignment. There's one announcement that we want to mention is that our quiz. Oh, go ahead.
I didn't fix that. I thought I did. It's
Where?
supposed to say the 30. Man, I messed up on your
Oh, yeah.
guys's. I'm
There it
sorry.
is.
Oh, by the way, Alexis and Daniel C, I do not have your birthdays. So make sure that you put those in the chat.
So we're going to be making a little change here to your agenda because this right now says that you have a quiz next Friday, but we're changing that.
If you refresh that.
Okay.
There you go.
Oh, you sent it to me, Alexis, but I'll let Doc know.
Oh, okay.
I don't know if you got it, but I'm sending it to you. There we go.
Thank you. And no, you guys, some of you guys, yes, like you guys have, the common, like picture of your stuff, but no, you still need to send me your birthdays.
Mm-hmm. All right, so there it is, it's updated. So our quiz, our second quiz that we kept saying is going to be next Friday. We actually moved it to the Friday after that. So in 2 weeks, not next Friday, but the Friday after that one. There's a reason behind that. And that's because next Friday is actually my last day as a student teacher.
No.
Yeah, so it's my last day that you guys will be seeing me. And I'm really sad about that. But it just means that I'm basically done with my semester, my school year. And I get to graduate and hopefully be a teacher, have my own classroom next year. But because we're like, it's my last day, probably shouldn't give them a quiz on my last day. We switched it, okay? So not next Friday, we changed that to Friday, April 30th. Oh, yeah, I'm gonna miss you guys. But Doc has given me permission to pop in and out of your classes from now until the end of the school year. She says that if I want to come back and teach a lesson, then I'm more than welcome to come back. And yes, so it's not gonna be the last time you see me. I'm definitely gonna be coming back a couple of times.
Or just hang out.
Yeah, and just to hang out too. All right. So because there is some lessons I would want to see your teacher teach. So I'll definitely pop in for that. All right, so we're gonna go ahead and get started on our first sorting activity. If you click on that, it'll take you to your class kick assignment. Some of you guys have completed it, so if you have, just make sure you're double checking the correct placement afterwards, after we do it together. But this is what it looks like. All right, and give me a thumbs up if you were able to open this up and you're ready to go. Give me a clap if you need more time so that you don't miss the directions for these. Okay, I'll give you more time. But if you did give me a clap, turn that into a thumb when you're ready, so I know.
While that's going on, guys, just as a heads up, because I'm pretty sure I'm probably going to forget because I almost forgot with the last period. Your progress report for today, I'm going to wait a few minutes after class for those of you guys who are going to be turning in your notebook, because a lot of you guys are already done with your notebooks or will be by the end of today. Make sure that you turn them in as soon as class is done if you guys are ready. That way it's not in your progress report. All right?
All right. All right, if you're just joining us now, we are working on the first assignment on our day for today in your agenda. So if you click on your agenda, the first thing we're doing today is this sorting activity. Make sure you see us here in this sorting activity. It'll take you to class kick, which looks like this. All right, so what are we doing here? You have a linear function side and an exponential side, and there are some pieces down here that you can click and drag. What you're going to do is sort the pieces below as linear or exponential by dragging them to the correct box. So you can click on this piece here, for example, multiplication pattern, and you need to decide, is that part of a linear function? Do you see a multiplication for a linear function? Or do you see that on the exponential function? So that's all you're doing with these pieces is clicking on them, dragging them to the correct spot. And I would suggest starting with the pictures since we've talked about those and know what that looked like in our Desmos activity, but it's up to you. There's also a little hint over here that says this box here on the linear side, you should have 8 pieces. If you have more than that, then you probably misplaced one. If you have less than that, then you're missing a piece and you need to bring it over. The exponential side should have 7 pieces. So make sure you count them at the end there to make sure you have the correct amount. And then that should tell you if you need to move something over or if you need to bring something over to this side. So I'm going to go ahead and give you guys about 3 minutes. And if I see that you guys are done ahead of time before those 3 minutes are up, then we'll just go ahead and review this. But good luck. Oh, this activity is due today by after we're done with it, so you'll have to turn it in. This is an in-class activity. I just clicked on view like that slide one and it made it bigger for me. So that's even
Yeah.
better.
The only thing I don't like about that view is that if you have, like, this one works fine because it's just on the top,
Mhm.
but the stuff on the bottom, you can't see and you can't move it
Yeah,
up, which is
that's true.
dumb.
All right, you guys are getting close to finishing that up, but you have 1 minute and a half, so a minute and third. Oh no, 15 seconds. Catherine, you're doing fantastic. Keep going. Danica, that looks perfect to me so far. Emily, fantastic. Yes, good job. Jade, very good. Jennifer. Oh man, you guys are doing fantastic on this one.
Okay, I want to give a comment. Someone just sent me a message saying that sometimes they're doing their work on Class Cake and their stuff is either erased or it goes back to where it was. I have seen that glitch. Honestly, it's because of like an internet connection where Class Cake doesn't like save 100% correctly. Um, Worst case scenario, guys. I mean, I know your guys' track record. If that ever happens, you guys can always send me a message and be like, "Hey, I did this activity. It just completely disappeared or like pieces got messed up." That's fine. Send it to me and I'll still give you guys credit. Now, if all of a sudden that happens every single time, no, I'm not going to believe you. Also, if you hardly ever do your assignments and you tell me, well, that's what's been happening to me every single time, again, I'm not going to believe you. But for those of you guys who, like the person who sent me that message, I know you're always doing your work. So, yeah, just send me a quick message and be like, hey, this happened. I mean, guys, come on. It's computers, things happen, glitches, Wi-Fi. I get it. Just send me a message and and I'll take care of you. Just communication is key.
Mhm.
So make sure that you guys are communicating to me those issues.
Mm.
Again, don't cry wolf. If you don't know what that means don't be a liar and like tell me that that's what's happening all the time. And no, you can't pull that once a week or like give me a pattern of some sort. Like I know how this works, okay? But if it actually is legit, that happens, send me a message and I'll take care of you. All
Yeah,
right?
I don't know if you guys have seen it with me, but sometimes when I'm moving something, it all
Yeah,
of a sudden goes back to the bottom. And like, what? It remember I said that class kick ghost. I think
yeah,
it have to do with the internet, just like Zoom lags,
yeah,
class kick lags as well.
exactly.
But when we have those pieces missing, then that's definitely the class kick notes. I mean the class kick ghost. All right, so we're gonna go ahead and get started. So what I'm gonna have you guys do is when I click on a piece and I'm trying to decide if it's linear or exponential, you guys can give me a thumbs up if it's linear, and you will give me a clap if that should be on the exponential side. Okay, so thumbs up for linear, clap for exponential. All right, let's just
Oh,
start with
and
the,
sorry, don't forget to go into Google Classroom and mark this assignment as done. Some of you guys haven't been doing that. So if you're done, go to Google Classroom and mark it as done.
yeah, if you want to know where it is, remember it's a sorting activity. So that's what it says here, linear versus exponential sorting activity. It's our first sorting activity. So you want to click on that, click on view assignment and turn it in. So far we have 8 of you that have already turned it in before today, and 1 of you that just did so since then. But let's start here. So when I'm looking at these, I probably would have started with the graphs, but that's because I have a very good understanding of what the graphs are. But I'm going to start in particular. Oh, see there? It was lagging. I'm going to start with this one here because it's a line. And all I want you to see is that a line here can be decreasing, can be going down. So thumbs up if this line that's decreasing is linear. Clap if it's exponential. All right, I see thumbs, I see one thumb. Unless I miss, oh, more thumbs, okay. Yeah, good job. So this is linear, a line is linear. All right, let's take a look at this next graph. This graph is not a straight line, has a curve to it. Thumbs up linear, clap exponential. I'm seeing some, okay, good job, Jimena. Catherine, thank you, Jennifer. Yes, perfect. Lizette, perfect. Yes, this is exponential. This is the major difference between the two graphs. A line is linear, a curve is exponential. So that should help us out with these here. This is another line, but notice it's going up. So we say increasing. Thank you, Catherine. Thumbs up linear, clap if it's exponential. Thank you, guys. All right, yes, this is linear. Last graph here, we have a decreasing, not a line, but a curve. Thumbs up linear, clap if this is exponential. Thank you, Catherine. Yes, Lizette Jimena, very good. So this is exponential. Big difference already, okay? And this is gonna help you going forward with today's notes and your turn. So if you can tell the difference there. All right, so now we have a whole bunch of words. We'll start with this one. Okay, a multiplication pattern. Think of your tables. When we thought of a multiplication pattern, was that linear? Give me a thumbs up. Or clap if that's exponential. Good job, Juan, Jimena. Yes, good, good, good. Perfect, Natalie. Yes, this is exponential. Good. What about this one here, a subtraction pattern? Thumbs up linear, clap exponential, a subtraction pattern. Good job. Yes, a subtraction pattern is linear. Very good. Well then, since I looked at that subtraction pattern, what about the addition pattern? Thumbs up linear, clap exponential. Oh, okay. Somebody clicked on one emoji and then all of a sudden switched it. Yeah, very good. This is a thumbs up for linear. If you had the subtraction pattern on the linear side, the opposite of that is addition. Both of those two there are linear. All right, what about this one here? A curved graph, a graph that has a curve. Thumbs up linear, clap exponential. Good job, you guys. All right, curved graph is exponential. All of these are curves here, so that curved graph should be exponential. What about this one? Some of you might think it's a trick question, but give me a thumbs up if this is linear, a y-intercept. Does that go on the linear side? Or clap if it's exponential, but I'm going to give you a different choice. Give me a different reaction if it should go in both. Okay, yeah, good. A y-intercept, both of these have a y-intercept, the initial value. So you're going to notice that there's two y-intercepts here. There's another one. There's a reason why there's two, because both functions have a y-intercept. So good job on that one. All right, next one, division pattern. Thumbs up linear, clap exponential. Division, and we're saying division because we know it should be, yes, good job. Exponential. So we're saying division pattern because we know we have to switch that division pattern to a fraction. All right, let me bring these up so I don't have to constantly come down. All right, next one. The graph is a straight line. This one might be pretty obvious for you guys, but it has the word line. Line, thumbs up, linear, clap, exponential. Yes, this is a straight line is linear. Constant multiplier. So now we're getting into the name of the patterns. Where does a constant multiplier go? Clap, linear. Sorry, thumbs up, linear, clap, exponential. Yes, good job, you guys. A clap. This is on the exponential function. So your multiplication pattern or your division pattern, those are called the constant multiplier. The last two here, we'll start with this one, slope. Thumbs up, linear, clap, exponential. What function has the slope? Yes, good job. Slope is a linear function feature. And then that leaves us with the rate of change or constant rate of change. So which function has a constant rate of change? Is it linear? Thumbs up. Clap for exponential. Yes, good job. A rate of change, remember we've talked about these two words. These two words mean the exact same thing, slope or rate of change. Okay, the big difference here is that multiplier, which is exponential. All right, good job, you guys. So this is what the correct sorting looks like. You guys are doing fantastic. You're telling the difference between these perfectly, which is awesome. So take a screenshot if you're for some reason the internet is lagging. As you can see, Doc is going in there and giving you guys a thumbs up if you did good. There it is. There's mine. Yay. So that's correct. I get the points for that. Make sure you go back into Google Classroom and click on that 1S L versus E function sorting activity. If you want to count, start from week 5, you would have to count 1, 2, 3, 4, 5, 6, 7 spaces down. That's your sorting activity. Click on view assignment and mark it as done. Turn it in because we're all done with that. And if you want to get ready for our next item here, then you can go back to your agenda and you can click on that week 5 notebook to get you ready. But I'll come back here. This is what it looks like completed. That thumb is moving around everywhere. Mark it as done. Make sure you get your points. That one was a class activity, so it needs to be done now. It's not a homework assignment. But those of you that did it ahead of time, good job, you guys. All right, don't forget to go back into your agenda, click on that week 5 notebook and see us over in your week 5 notebook. This will be our last day of notes for this week. And by this point, after today, you should be able to turn it in. And we will be on page 4 to start off with. But again, I'll keep it up here if some of you guys were working while I give you guys time to get to the notebook. All right, Catherine, I see you in Class Kick for your notebook. Thank you very much for joining us there. Jade, I see you there. All right, you guys are slowly coming in here. All right, give me a thumbs up if you're ready here on Class Kick, ready to get started with your notes. Give me a clap if you need more time to get to your Class Kick week 5 notebook. All right. Awesome. Okay, so I'm going to go ahead, close that up there. All right, so as you can see, we still are working with linear versus exponential, but instead of looking at tables, we're going to be looking at the graphs. Okay, but it's not any different, which is why we wanted to make sure you understood tables really well, so that when it came to graphs, you saw, oh, okay, graphs aren't that bad. I know a lot of you told me in that All About Me, I don't like graphs. They're not that bad. And you're going to realize that after working with your tables and how much work we did with that yesterday, that these are pretty simple and not too bad to work with. Okay, yeah, thank you. So just make sure you're participating too, and that'll help me move faster too. Good job, Jimena. All right. So we're going to go ahead and get started. Is that new? No? Oh, okay. All right. All right. So today is our 11th day of taking notes for this quarter or semester, and we are working on our linear versus exponential unit. Okay. So we're still looking at how these two functions are different or similar, and we're going to be looking at them in their graph form instead of the tables. So your objective for today is to be able to say that I can distinguish between linear and exponential functions. Can you still tell the difference between a linear graph and an exponential graph? And can you find their rates and initial value? So exact same things as we did yesterday. There's two steps that we're taking. Okay, you're looking for first the initial value. That's usually the easiest part when you have a graph to find your y-intercept. Notice it's still color coded as blue, and there's a lot of blue here, which we can make those connections and find that easier. Right now, the color coding helps you out. Eventually, we're going to get rid of those color codes and you should be able to find them on your own. But that first step is to look for your y-intercept. And the second step, depending on if you have a line or if you have a curve, then you're going to find a rate of change, or you're going to find a constant multiplier. Remember, a rate of change in our sorting activity, we said that's linear. When we put our constant multiplier, that was on the exponential side. So two steps still, and they're very similar to your tables. All right, so we're going to get started on the linear side here. Okay, want to remind you guys that when you read a graph, you start on the left side, and as you move to the right side, it's telling you if it's going up or down. This is important, and it's not that it's important, but it's also very helpful to you guys to determine if you're going to have a positive slope, a negative slope. It also helps you determine if you have a regular multiplication pattern or if you have to switch it to a fraction pattern. So all of these strategies that we point out are to help you guys out in deciding and not to feel too lost. All right, so when you're looking at a graph, start on the left side. You can follow it with your finger. What movement is this making? We're coming up. Because this line is coming up, we know we should have a positive slope. So remember that trick of writing the word slope on here? That tells us if it's going to be positive or negative. This is a positive slope because it's going up. But we also say this is an increasing linear function. It's a line and it's going up, so that's increasing. All right, so once you identify it's increasing because it's going up, you can move on to our first step, the initial value. That's usually the easiest one when you're working with the graph. That's going to be your y-intercept. So right now your y-intercept here is colored blue. This graph has a blue point. That should help you out. But why is that called the y-intercept? Because if you remember from last time before we went on spring break, when you go down the y-axis, you find that point where your line crosses your y-axis. In this case, it's 4. So we say that point 0.04 is our y-intercept, or you could just say the y-intercept is at 4. We're making sure we're noticing that this is a positive 4. So we have that +4, that positive 4. So how many of you are remembering this from before spring break? Give me a thumbs up if you remember. Give me a clap if you forgot it during spring break. This is our linear functions. And you guys did really good on your test, on your quiz for linear functions. The majority of you did. But let's say you struggled with linear functions before spring break. I told you, hey, don't worry too much about it because when we come back from spring break, you're going to keep working with them. We're still working with them now. So y-intercept, come down. That's where your y-intercept is. All right, the second step is to find the rate of change, which is a slope. And we know it's a slope because this is a line. So guys, remember our slope, we could do that from finding the rise over run. You need 2 points to find your rise over run. So I'm going to go with this blue point and I'm going to go with this pink point. To find the rise, I need to ask myself, do I go up or do I come down to get from this blue point to this pink point? 2 points right next to each other. Well, let me get my pencil. We even use some color coding here. Our rise, I'm going to go 1, 2, up 2. So if I'm going up, then I know that's a positive 2. And then from here, I need to either go to the left or to the right to get to that pink point. If I go to the left, I'm going further away, so I'm going to the right. Think about your home and we want to get to Starbucks. The blue point is your home. That second point is Starbucks. What are the directions to get there? That's your slope. So we're going to go 1, 2, 3 to the right. That's a positive 3. So we get that our slope is a positive 2 over 3. Lots of review here from your lines. So this part here, once you have your slope, once you have your y-intercept, you can write that linear equation. And we're actually giving you these baby steps to help you write the exponential equation, which will be a new type of equation next week. Because if you can easily find these 2 pieces of information, writing the equations will be a piece of cake, but for some reason, sometimes students would struggle writing equations. But I think for the most part, you guys are noticing they're not that bad. All right, our equation for a line, remember this, the y equals mx plus b. M here is the slope. B was the y-intercept, or is the y-intercept. That is still the case here. We have our slope, we have our y-intercept. You just put them in the correct spot. Remember, your slope is the number in front of the x, your y-intercept is at the end. So my y-intercept there should be behind that x plus 4, and my slope right in front of it. Y equals 2 over 3x plus 4. This here is just review from the last unit. So let's go on over to your class kick side. Let's drag those pieces over. Our objective was to distinguish between linear and exponential functions. We looked at the increasing linear function here. Why was it increasing? Well, because when I take a look at this line and I write the word slope, I know it's going up. Our y-intercept is our first step. I come down this y-axis and I find that blue point there, which is y-intercept at 4. The rise over run, I do want to see that, and I want you guys to continue practicing finding the slope. So I want to see you write the rise and the run here. So let's say I pick these 2 points here. Oh, my word slope is in the way for now, so let me get rid of that. So I'm going to pick this point. This is my first point. This is my second point here. I'm going to go from one point to the other by going up one, up twice. I went up, so that's a positive 2. And I'm going 1, 2, 3 to the right, so that's going to be a positive 3. That's where our slope comes from, the 2 over 3. There we go. And since you have these two pieces of information, you can write that linear equation already. Slope goes in front of the x, 2/3 x, and the y-intercept, that positive 4, goes behind the x. So a lot of review. And if you struggled with linear equations, they're not going away. We're going to keep working with them. Let's take a look. All right. And I'm noticing that a lot of you are just following along as I'm showing you the PowerPoint and just dragging the pieces already. You're not waiting for me to come to the class kick side, which is awesome. That kind of makes us move a little faster. So if I'm showing you the PowerPoint and you're seeing where all these pieces go, don't wait for me to come over here to do so. That makes us move faster. All right, so since a lot of you are done with that, I'm going to go ahead and move on to the exponential side. All right, we're not writing the equation for the exponential side just yet because I don't want to throw too many things at you at once. Some of you, though, are getting to understand it really well, which is really good. That's just setting you up for success later on here, which is good. All right, we're going to take a look at the exponential side. Why is it exponential? Well, it's exponential because when you look at the graph, we see it's curved. It's not a straight line. So that's why we know it's going to be exponential. So just by looking at the shape, you know what it is, exponential. Now, what you do want to know is that when you read a graph, again, you start on the left side. If you start on the left side here, follow it to the right side, think of the movement you're making. You're coming up. It's like going up a mountain. When you're going up the mountain, up a hill, okay, we're getting higher. So we say this is an increasing exponential. Why is that important? It's actually a really good strategy when you're thinking about what your pattern is going to be. When we're increasing, we're getting bigger. That's going to help you determine what kind of pattern it has, especially in the other one. All right, so first step, same first step, start with your initial value. That's your y-intercept. So if I'm looking at this y-axis here, I'm coming down this y-axis to see where does my curve touch that y-axis, and that is right here at 0, 1. So my y-intercept is at 0, 1. First step, easiest step. So give me a thumbs up if you're okay with finding the y-intercept. Give me a clap if you struggle with finding the y-intercept after these two examples. Okay, cool. No claps, I see thumbs. If you did, if you're somewhere in the middle, then you can give me another reaction. All right, perfect. Okay, that just means we keep working with these. All right, so come straight down the y-axis. We see a point on that y-axis. That is our y-intercept. So now comes the rate, the constant multiplier. How do we find out what the constant multiplier is here? Well, let's think back to our tables. Our tables was finding a pattern in the y's. We can still do that here. We just have to find our y's for this table. So here, let me get this. There we go. There's our pen. But what I want is to change the pen color. All right. So how do we find our y values? Well, all of these points here have y values. So if you start on the left side, and you are going up this graph, your first point shows you have this y value of 1. This second point here, if you line it up to your y value, that's a 2. If I keep going up here, this point has this y value of 4. Keep going up. This point here, match it to a y value, has that y value of 8. So we still have y's, just like your table, and we can write them down on the side somewhere and find their pattern. So when you write them down, remember, read this graph left to right. So we start here at the 1, the 2, the 4, and the 8. So I want you guys to write them down here. 1, 2, 4, and 8. And I want you to keep in mind that we're looking for a multiplication pattern. But how did we know it's multiplication? Because it's exponential. And it's a multiplication pattern because we're going upwards. It's increasing. So those are a couple of strategies to pick up on. All right, anybody here that wants to tell me what the pattern is from 1 to 2? What are we multiplying by? From 2, oops, no, I gave it away. From 1 to 2, what are we multiplying by? If you guys were paying attention to Zoom, then you know what the pattern is already. Or even if you're looking at your notes, it's not that hard to find it. But what can I do to that 1 to get me a 2? What can I do to that 2 to get me a 4? What can I do to that 4 to get me the 8? Yes, good job. Yeah, so we are multiplying by 2 each time. And that is your y pattern, your constant multiplier. Remember, multiplication. And there you go. So when you're thinking ahead, for those of you that want to think ahead, by the way, I knew before too. Okay, that's perfect. See? For those of you that are thinking ahead, if you have this 2 here as your constant multiplier, and if you have this 1 here as your y-intercept, you're basically ready to write the equation of this graph. I just haven't given you the equation like this, but it's similar to y equals mx plus b, okay? It's not too different. All right, let's go to your exponential side. Some of you might be like, well, why don't you give me the equation? Because baby steps. We're noticing that it makes you guys, it has been very successful in how we broke up these lessons for you guys. If I throw too much at you at once, I don't want to lose you. All right, our y-intercept was 0, 1. We know this is increasing, so we're going to be looking for our multiplication patterns in our y's. I do want you to zoom in here and circle those y values so you know how to find them on your own. When I'm following this graph, this is the first y value this point shows me. This point shows me the 2. And actually, with the other class, I used a blue, and that seemed to stand out a lot, and students were easy. It was easy for students to see. So this 2, if I line it up to the y, sorry, that point, if I line it up to the y, gives me a 2. The next point lines up to that y value of 4. This last point here lines up to that y value of 8. So when I'm writing them down, oops, I have the 1, 2, 4, and 8. Why is it in that order? Because we're going up. So that order is important. So 1, 2, 4, and 8 are your numbers. Oh, see, that moved on me. There we go. That had the multiplying by 2 pattern. This seems to be acting funky with me now. And that gives me a constant multiplier of 2. There we go. So that's what it looks like completed. Make sure you're going in here and circling these here just to help you remember, because anytime we have quizzes or anytime you have exams or tests, whenever you have homeworks too, you can always come back to your notes to help you out if you forget something. It's normal. You're not going to remember something the first time you've seen it. Good job, Lizette. Good job, Juan. Jade, fantastic on circling those. Thank you. Marifed, very good. Natalie, good job. Sammy, good job. Keep putting those pieces in the right spot. All right. So if you're understanding how to work here on the increasing side, the bottom portion is very similar, but now we're looking at the opposite of increasing, which is decreasing. But it's still the same 2 steps. All right, give me a thumbs up if you're ready to move on. Give me a clap if you need more time finishing up this piece here. Thank you, guys. All right, here we go. So you've seen the increasing graphs because from the left side to the right side, we're going up, whether it's a straight line or a curve. But not all lines go up, not all curves go up. So we're going to take a look at the opposite scenarios. So I'm going to take a look at this graph here on the right side. Notice it is on the linear side because it is a line. Line means linear. So you can just take a look at that graph and know it's a line, so it's going to be linear. But is it increasing or is it doing something else? We'll start on the left side. With your finger, follow that line. It's coming down. Because this line is coming down, we say it is decreasing, coming down. And if you'd like, when you see these straight lines, you can always go in here, write the word slope, and it helps you see too that it's coming down. So that also tells you something about your slope, that it's going to be negative. So some of you on that quiz, which you're able to go back to and take a look at any feedback I gave you, some of you on the quizzes would forget the negative for your slope. You found the correct rise and the correct run, but you were forgetting those negatives. So be careful with that. All right, so now that we know this is a decreasing line because it's coming down, let's take our 2 steps, and that first step is find your initial value. So your initial value is your y-intercept. So go down that y-axis, come down until you see a point on that line that crosses your y-axis, and it's at this point here. Coming down, we see this point is our y-intercept, that is at 0.5. And because it's a positive 5, we just say the y-intercept is at positive 5, just 5. All right, so now the slope, which you guys seem to do really well on. Remember, for slope, you need 2 points. Find your directions of that your home to get to Starbucks. That's your other point. How do we go from your house to Starbucks, or from your house to In-N-Out, your house to the mall, whatever it is you want. Let me change my colors since the colors work for you guys. All right, so from this point, I'm not going up, and I'm gonna have to come down. So because I'm coming down, that's a -1. Down, negative. And then that's your rise. Now we find our run. That's going to be 1, 2, 3, 4. 4 spaces, and I went to the right. Because the right is positive, then I say +4. So rise over run. When you're getting ready to write your rise over run, you need to make sure you have that -1/4. So give me a thumbs up if you're okay with slope. Give me a clap if slope confuses you. Give me a different reaction if you're, I get it, somewhere in the middle. Sometimes I can get confused. Okay, that's fine. Just remember your directions for run. When we're going to the right, that's positive. When we're going to the left, that's negative. When we're coming up, that's positive. When we're coming down, that is negative. But you need 2 points. So on this graph, you would have to get 2 points and ask yourself, how do I get from one point to another? But always remembering rise is on top and run is on the bottom. All right, so we have those 2 things we need for this equation, y equals mx plus b. M, your slope goes in the front of the x, that's negative 1/4 x, and your y-intercept goes at the back of that equation, so it's the positive 5 plus 5. Let's go on over to your notes. Decreasing here, we have a slope of negative 1/4, our y-intercept at 0.5, plus 5 here, and that one. Don't forget, show yourself how you found that slope. That's going down 1, so that's a negative 1. And we're going over 1, 2, 3, 4 to the right. So that's a positive 4. That's how you get your slope. If it helps you, write down the word slope to show you that it's going down. All right. Waiting on a couple of you. I see you guys dragging those pieces over. All right, give me a clap if you need more time to complete this portion. The decreasing linear functions, give me a thumbs up if you're ready to move on. All right. All right, so we're going to move on to the exponential, which is the newer part, really. That was just review for the linear side. So the exponential. So this part is where I really want you guys to focus in on, because this is where we find the students making the most mistakes on. Okay. It is a curve. So we know that is exponential. But this is a decreasing exponential because this curve here is coming down. So I always like to say, think of when you're at the water park and you have those slides where you come down. By the way, I was always afraid to go down those water slides. I never have in my entire life actually gone down those water slides. So let me know if it's fun in the chat or scary or painful. I always think they're painful.
That's without the tube, right? Just the one that you just slide.
Yeah, exactly.
Oh yeah, no, I don't do those.
You don't do those? I don't at all, even with the tube. I'm too scared. But think of those water slides. You're at the very top and you're coming straight down, and then that nice little curve, you know, you're making it to the pool. Okay. When you read a graph, start on the left side. This is the left side. It's coming down. So that is a decreasing exponential function. So when you know it's a decreasing exponential function, okay, when it's coming down, it does have that multiplication pattern, but it's the division pattern. And when we have that division pattern, we need to make sure we write it as a fraction. We need to switch it as a fraction. So keep that in mind. Whenever you see a curve that is coming down, you know you're going to have a fraction as your multiplier. We see a lot of you guys noticing the division pattern, but you forget that that should be changed into a fraction. So keep that in mind. All right, let's start with the first step, the y-intercept. Here's our y-axis. We're coming down that axis and noticing that point 0, 9. Or we just say the y-intercept is 9, the positive 9 here. That's your first step. Pretty nice, easy first step. We're just looking at it and we see that point on the y-axis. That's our y-intercept, our initial value. Okay, how do we find the constant multiplier, your y pattern? You need to find your y's. So when you're looking for your y's, match those points to your y-axis. So let me show you here. When I go up, when I start on the left side, here's my first point. So my first y value is 9. Coming down, here's another point, match it to your y value, that's 3. Coming down, match it to your another y value, that's 1. If I come down, there is that other point here, but when I match it, it's somewhere in the middle. That's either a decimal or a fraction. You don't have to worry about those. Just those actual numbers you can actually see. But technically, that's probably like 1/3, but not that important. All right, we know we're coming down, so keep in mind, this is gonna be one of those fraction patterns. It's a curve, so it's gonna be a fraction pattern, that multiplying by a fraction. But let's take a look at how it works. So our first point here, our first y value is 9, then 3 and 1. Let's write those down on the side, 9, 3, and 1. Notice the order I wrote them. Why did I write them in that order? Because I'm starting on the left side. The left side is showing me a 9, coming down 3, and coming down 1. So what is the pattern from 9 to 3 and 3 to 1? Anybody that can let me know in the chat, what can I do to that 9 to get me 3? What can I do to that 3 to get me 1? And if you can't see it that way, then you can also think about it the way, I forgot who it was that mentioned it yesterday. We can go backwards, 1 to 3, 3 to 9. That might be easier for you guys to tell. I know I'm multiplying by 3 here, multiplying by 3 here. Yeah, good job, Juan. So if I'm looking at it the other way, I can take that 9 and divide it by 3. Can take that 3 and divide it by 3 to get me 1. So this is our division pattern. But when we have division, we change it to a fraction. So all you have to do is put a 1 over it. Put a 1 over it. That's it. We're not complicating it for you guys. Put a 1 over it. And that gives us 1/3. So keep that in mind. This is a good strategy. You see the curve coming down, you know it's going to be a fraction. And you do have one of those in the your turn. All right, let's finish this off and we'll talk about the your turn and then your homework assignment. So this is a decreasing exponential function. Our y-intercept, that blue dot, is 0, 9. So I'll drag that P09. Because my curve is going down, I need to remember, oh, I gotta be looking for that fraction pattern, the division pattern. All right, and I need to get my y values to find that pattern. So make sure you look at those points and match them to your y's. There you go. We notice it's 9, 3, and 1. So let's get that 9, 3, and 1. Write it down on the side, 9, 3, and 1. Look for that pattern. It was to divide by 3 each time, which actually just means I switch it to a fraction with the 1 over it. That's it. And there you go. So this is what your notes look like, fully completed there. If you're having connection issues, then you can go ahead and take a screenshot of that now. If you guys have any questions while I'm waiting for some students, you can always unmute yourself or let me know in the chat too. If there's anything you want me to clear up. All right. I see you guys finishing up. All right, give me a thumbs up if you're ready to move on to the your turn. Give me a clap if you need more time finishing these off. Oh, yes. When we have fractions, there's definitely still simplifying, especially in your slope side, yes. But you don't have to simplify if you pick points that are close to each other. Good question. Yeah, our slopes will always have to be simplified. These fractions for your constant multipliers, you really don't have to worry about simplifying those because you're just putting a 1 on top when you're dividing. But for example, the your turn, yeah, if you have a fraction where you pick points that are far away from each other, you'll have to simplify. All right, let's go ahead and move on over to the your turn. So we have 4 different graphs. And for each graph, I'm asking you to tell me if the graph is increasing or decreasing. That's actually the easier part. That's just looking at the shape. You don't really have to do any calculating there. Look at your shapes. Going upwards means increasing. Going down means decreasing. The nice part here is this second part, the type of function. This is probably going to be the easiest one for you guys. What type of function is it? Just look at the shape. Curve. What is that? Line. What is that? So you're just circling increasing or decreasing. You're circling linear or exponential. Here's another thing. Some of you were telling us, well, sometimes I'm still confused if it's a multiplier or rate of change. How can I tell? Here's another strategy, which is pretty obvious. So here's the word exponential, right? If we're saying it's exponential, then it's going to have a constant multiplier. They're right next to each other. So if we're saying something is exponential, then it's going to have a constant multiplier, and you don't even have to worry about that top part. If you're saying the function is linear, then you know right next to it is that rate of change. You don't have to worry about this constant multiplier. So there are boxes and squares where you're filling it in, but you don't have to fill it in for every single thing if it doesn't need an answer there. We don't need an answer here. Okay, so keep that in mind. After that, find the constant rate of change, either the slope or the pattern, and the initial value. We're running short on time here, so I'm going to go ahead and go through the last one because I know that could be the hardest one. So when we look at this last one, I'm going to ask you guys for some help here. Let's start off by deciding, is this increasing or decreasing? Well, I'm on the left side and I'm coming down. Is this thumbs up increasing? Clap decreasing. What would you circle? Thumbs up for increasing. Clap for decreasing. And if you're not sure, you can always go back here and take a look at that shape. What do you notice? Which one is it? Yes, good job. So you're going to want to circle decreasing here. Another simple one. What type is it? Thumbs up for linear, clap for exponential. That's the shape. Linear is a line, curves are exponential. Good job. All right, we're set on that one. So now it's exponential. So that right away tells us, oh, we're going to have a multiplier. So forget about this. You don't need that. Don't worry about it. So what is our multiplier? Well, you can come back here. We know it's this one now, decreasing, and it's coming down. It's going to be that fraction pattern. We need our y's. So I'm going to zoom in. I know it's hard to see these numbers, but that is the number 16. Keep coming down to that next point, match your y value, that's the 4. Keep coming down here to this next point, match it to a y, that's a 1. So what is our pattern here? From 16 to get to 4, from 4 to get to 1. What pattern do we have? Let me know in the chat, or you can unmute yourself. If you're confused with that, you can always see it the other way around. Going up, going up. Yes, good job. Divide by 4. I know you guys are coming back and forth between ClassKick and Zoom, and that's why there's that delay. Yeah, good. It's divide by 4. So some of you might be tempted to click on that and say, oh, 4. See that come up red? It's red because this can't be 4. If you're dividing, we had to switch that to a fraction. So we need to come back here and say, oh, let me just put the 1 on top. Let me just put the 1 on top. And we can go back in here and retype that as 1, the slash, and the 4. And now it's green. It's 1/4. And the last thing you want is your initial value. That was your y-axis, your y-intercept, sorry, which is 16. So we'll come here and type in that 16. All right, so I know we're running short on time, but the rest of these shouldn't be too bad. You do have your notes to help you guys out. We're gonna be taking a look and see how you guys are doing. If you have questions, you can also type them on the side there. I'll try to answer them over the either today or over the weekend. Let us know in the reflection if you have some questions. You do still have to complete a reflection. But see, this is from last quarter. We weren't that nice to them. We didn't give them sentence frames. This is what they had to do. They had to come up with a sentence and tell us, oh, this is what I learned today, or oh, I learned this, but I have a question on that. Okay, but think about it. Give me a word that you learned today. Give me a strategy that you learned today. And there's a lot that I pointed out. Give me a question you have. So that if you finish with these here, you're finished with your notebook. And then I want you guys to, I'll open it up for you guys, but I want you guys to pay attention over here so I can show you how to complete today's homework. Today's homework is another Google Forms, which all you have to do is type in your first name, last name, and your directions are actually here in this first page. Okay, it's asking you to identify if the table is an exponential function by saying yes or no. We just want to know if it is exponential. So for example, here is the table. Think of your pattern in the table. It's multiplication or division. Do you see multiplication here? Or do you see division? If it is multiplication, then that's going to be a yes, this is exponential. If you see it's division, then you click on yes, it is exponential. Let's say you have something else, something crazy is going on here. Sometimes we're adding, sometimes we're subtracting, sometimes it's neither. We don't care if it's anything else, because if it's anything else, we say no. But if you see it's multiplying or dividing in your Y pattern here, then you're going to say yes. You have 4 of those tables here. Look for multiplication, look for division. If you see those, say yes. All right, but that's it for your homework there. This is the last part of your notes. You're responsible for completing these 3 problems here on your own. As soon as you're done with those problems, then you're done with your notebook. Make sure you review all those other pages. And let us know if you have any questions in the chat before you go, or you can unmute yourself. But don't forget you have an exit ticket that you must fill out. Fill out your exit ticket.
And then your progress report will be sent to you guys here in a few minutes once I've had some people submit their notebooks. But have a good day, guys. Have a good
Bye,
weekend.
guys.
I'm assuming he's saying bye.
Did Juan leave? I saw him raise his hand in the.
Juan? Yes. But I didn't kick him out.
No. He was raising his hand, I guess. Oh, no, he's doing it right now. Oh, interesting.
I'm putting everyone in the waiting room.
Okay.
There we go. And